Hey, welcome to The Explainer. Today we're jumping into something that's a cornerstone of modern networking, the virtual LAN, or VLAN. It's kind of like the invisible architecture that keeps our digital world organized, speedy, and most importantly, secure.
Okay, so to really get this, let's start with a simple analogy. Picture a huge open-plan office. Total chaos, right? Every conversation, every announcement over the loudspeaker, everyone hears everything. Now, a VLAN is like putting up invisible, soundproof walls to create separate departments. You've got sales over here, engineering over there. They're all still in the same building, using the same electricity, but the conversations inside each department, totally private and isolated from everyone else.
All right, so here's the game plan. We're going to start with the basics, what a VLAN really is. Then we'll pull back the curtain and see how they actually create all this order. After that, we'll get into why they're so critical for pretty much any network. And we'll tackle that classic point of confusion, VLANs versus subnets. Let's do this.
Okay, so what is a VLAN really? Let's move past the office analogy and get a little more technical. How do we build those virtual walls with actual network gear?
Right. The official definition can sound a little heavy, I know. But the part you really need to grab onto is broadcast domain that is partitioned and isolated. What that really means is you can take one physical network switch, one box, and use software to slice it up so it acts like a bunch of smaller, completely separate switches.
So, check this out. On the left, you've got your standard network, one big group. Every device can talk to every other device. This can get messy fast, not to mention it's a security nightmare. Now look at the right. That's the same physical hardware, but we've used VLANs to create these two clean, logical, and totally isolated groups. The devices in VLAN 10 can chat all they want, and same for VLAN 20, but they are completely invisible to each other.
So this whole isolation thing, it kind of feels like magic, doesn't it? I mean, how on earth does the switch know which data belongs to the sales group and which belongs to engineering when it's all flowing through the same wires? Well, it's not magic, but it is a really clever trick. The secret sauce, the entire trick behind it, is something called frame tagging. See, as your data zips through the network, it's broken into little packets called frames. The switch just adds a tiny digital label, a tag, to each and every one.
And this is so important that there's an official rulebook for it. It's called IEEE 802.1q. Yeah, it's a mouthful, but it's just the universal standard that all network gear uses for this. So when a chunk of data from your computer hits the switch slaps on this tiny 4-byte tag, and that tag basically screams, "Hey, I belong to VLAN 10," to every other switch it meets.
And here you can see it in action. The second that traffic from the laptop in VLAN 10 hits that first switch, bam, it gets a 10 tag. And traffic from the laptop in VLAN 20, it gets a 20 tag. That tag is like a passport. It stays with the data the whole way, making sure it only goes where it's allowed and never mixes with other traffic. Then, right at the very end, just before the data gets to its final destination, the last switch strips that tag off. The computer at the other end never even knew it was there.
All right, so we get what they are, and we kind of get how they work, but why? Why go to all this trouble? What's the big deal with splitting up a network anyway?
Well, the benefits are huge, and they really fall into two big categories. First up is security and performance. You can put all your sensitive HR and finance data on one VLAN and keep it completely walled off from, say, the public guest Wi-Fi. It also keeps network chatter contained, so your whole network doesn't grind to a halt. The second category is all about making life easier. You can group devices by what they do, not where they physically are. An accountant could be sitting right next to an engineer, but their computers are on totally separate virtual networks. And if someone moves to a new department, it's a few clicks in a software menu, not a whole weekend spent rewiring the office.
Okay, and this brings us to probably the #1 question people have when they're learning this stuff. What's the difference between a VLAN and a subnet? They sound like they do the same thing, right? The key, and I mean the crucial difference, is all about where they operate. Let's go back to our office analogy. A VLAN is a layer 2 thing. Think of that as the physical desk number inside the building. It organizes traffic locally. A subnet is a layer 3 thing. That's like the building's street address. It's for routing mail between different buildings. They almost always work together. In fact, best practice is usually to have one VLAN for every subnet, but they solve different problems at different levels. Okay, let's bring this all home. We're going to move away from the diagrams and take a quick peek at what this looks like when you're actually setting it up. It really doesn't matter what brand of switch you're using. The logic is always the same. First, you create the virtual network, and you give it a number, say VLAN 10. Simple. Second, you give it a friendly name like Sales VLAN, so you actually remember what it's for 6 months from now. And last, you just tell the switch which of its physical ports, maybe ports 1 through 8, belong to that VLAN. Done. Anything you plug into those ports is now in its own private network.
But wait a minute, what if you do need the sales team to talk to the marketing team sometimes? For that, you need a router to act as a go-between. Now, don't get hung up on the code you see here. The only part that really matters is that .1Q bit. That command is basically you telling the router, hey, I need you to understand the language of VLAN 10. This is what builds the gateway, letting you control exactly what traffic is allowed to cross between your otherwise isolated networks.
So if there's just one thing you walk away with today, let it be this. VLANs are all about breaking free from the limits of physical cables. They let you build a network that makes sense logically, a network that's organized around how your company actually works, not just where the desks happen to be. You see, getting a handle on VLANs, that's really your first big step into this much wider, wilder world of modern networking. And it leaves us with a really interesting question to think about. In a world of cloud computing and software-defined everything, where does the physical network even end, and where does the logical one begin?